Hello, myself, Mansuri. I am a third-year student of IIT Guwahati, Bachelor's in Data Science and Artificial Intelligence. This video is about my term 3 project, tri-semester 9. My project title is Predictive Maintenance using Machine Learning to Anticipate Industrial Equipment Failure. So, again, my introduction. Problem statement. The goal is to predict industrial equipment failure from sensor data. The core challenge is severe class imbalance. Only 3.4% of sample are failures. A naive model reaches 90% of accuracy while missing every real failure. Primary metrics required. So primary metrics is required. A missed failure costs more than a false error. Tools and technology, what I use, the language is Python. Modeling, I use scikit-learn, and I use random forest, logistic resistance, randomized search CV. For gradient boosting, I use XGBoost. Imbalance handling, I use imbalance learn SMOTE. Data and visualization, I use pandas, numpy, matplotlib, and cbor. Dataset I use Kaggle database, public database called AI for I-2020 Predictive Maintenance Data. It has 10,000 observation rows, 14 columns. This contains 3.4% of failure. Pre-processing, ID to top, ID columns, one for pen coding, or machine time, remove failure subtype to avoid leaking. And I also did the feature engineering power and temperature delta and the weird state buckets. For splitting the data, I use 60 for train, 20 for validation, and 20 for test. Let me take you to my code. This is my code. So as I said, I start with the downloading and importing all the important libraries, including pandas, numpy, matplotlib, and Kaggle, and scikit-learn, and XGBoost from XGBoost classifier. Here I'm loading the data, the columns, pre-processing, and dropping a few columns. And here I am I'm separating the database into two parts, X and the Y. Y are the targeted. As you can see, the normal is 96.6%, and failures are only 3.4%. Now here I'm splitting the data, training, validation, and test, which I already gone through in my PPT. And this is a continuation of my term two project. Like the term 2 project, I just stick to the random forest, but here I'm expanding to adding more columns with randomization search, more models with randomization search, plus XGBoost for the gradient. Here I created one database, one for master log, where I can store all related information related to all the models. I also done the fine tuning of the few of the models to get the best of it. Here the raw log result. This is the class for the log. From the term 2, I already have the code, which is for random forest. So this is about loading the random forest without SMOTE. Now, the next is I am adding the SMOTE. SMOTE is a synthetic minority oversampling techniques where it creates the data's point which are not available in the failure minority data's point into the database, which helps models to learn better the failures. So here you can see before SMOTE, only 203 failures are there, but after SMOTE, it's reached to as equal to the norm. It helps models to learn the better way. So now the models train. So here the first one is a random forest. Second one is XGBoost plus SMOTE. First was a random forest plus SMOTE. Second one is a XGBoost plus SMOTE. And here I'm loading all the after loading the models. I am results and I am logging into the one table, which we will see at the last. Here I also use the logistic regression without any hypertuning. Now all the model I'm doing some hypertuning, find the best model, and I'll also use the randomized search CV. Now let's go back to the directly to the results to cut short. So these are the results, and random forest from the term 2 with the class is balance, and all the fresh threshold was 0.005. Recall I got 94, but the F1 was very low. So here in this term 3, I took a target, I took a challenge to increase this F1, have to have a backdoor accuracy. So as you can see, I done with the random forest, with the SMOTE, execute with the SMOTE, logistic regression with the SMOTE, and understand. So all of this one by one I found true. Here I got a very good result in recall, is 97 in logistic regression, but F1 is very small. So this is not usable. So finally, we selected this one for the model tuning, for the model, base model. Is 0.80, I got a very good 0.80 plus, and the accuracy, the F1 score accuracy is 75, 0.75. So this was a very good example. Let's go back to my PPT to go to move forward. So this is the best result, what I output and the result. The base result we got from XGBoost. Recall is 0.80, and the F1 score is 0.753. Where ROC and PRAOC is also very good. So this is the best model what we got. Okay, evaluation matrix, I use the confusion matrix, dropping too many false alarms. This is the evaluation matrix. Too many false alarms make model impractical to deploy. Right? XGBoost balance the precision plus recall made it deployable model. The limitation of this SMOTE is the SMOTE is a linear interpolation, may miss the non-linear failure patterns. So it generates data points between the two minority points, but that are coming to the linear line only, which totally miss the non-linear patterns. Future work, the featuring is validating the same models validating into the real factory data. Okay, that helps us to know that whether this model are actually working or not. And I would like to also explore the light GBM and cat boost and cross sensitive. So this was all about my project. Thanks for